Welcome to Easy Math TV. This is our exploration of the standard normal distribution as part of our statistics series. And we're going to start by just making a graph of the standard normal or the bell curve. And what we need to know to get set up for this is that standard normal values are on a continuous scale. It's a continuous random variable. And when we're dealing with a continuous random variable, it doesn't make any sense to talk about the probability of one single number. So, for example, if I asked you what is the probability that z would equal positive 1 exactly, there is no such thing. You can't discuss that because it's a continuous number, and probabilities of individual outcomes make no sense. If we had been if we had actual data that was considered to be normally distributed, you would see histograms that have binned data. So you would need to put the data into bins in order to create a histogram. But we're not going to be creating a histogram tonight. We're going to be actually showing how to create the z curve using Excel. So the random variable is named capital Z. Capital Z is just a very specific name that's given to the standard normal random variable Z. So values of Z typically will fall between -4 and +4. Really, you're not going to see many values that go beyond -3 and +3, but we're going to go all the way out to -4 and all the way up to +4, just so that we can see what the curve looks like. And really, those are not hard and fast endpoints either. Z can actually go as far down as -10 or -20. And all the way up to +10 or +20. There's no limit of the values of Z, but the probabilities of those occurring are very, very rare. So we're not even going to go past these points. So the first thing that you're going to want to do is create your column A here, just like you see here. In row 1, I have typed like basically descriptions of what you see. So column A is our random variable values. Column B is our probability curve value. It's called a density function for a reason, because those probability curves are going to help us to calculate probabilities for values of Z that fall between two values, and probabilities of Z that fall to the left of a specific value, the cumulative probability. So we're going to be able to calculate those as area under the curve. But we need to be able to graph it. So in order to graph, we need the y values. So column B is going to give us the y values of our curve. Column C is going to give us our cumulative probabilities. And eventually we will get over here to the probability between two z values, but that's going to be a future video. So for today, we're just going to talk about these three: the random variable itself, the probability curve value that's going to help us to make the graph, and then the cumulative probabilities and what those mean, what those numbers represent. Okay. So in row 2, these are my headings that are actually going to go onto the graph. So in A2, I just typed Z, and then in B2, I typed P of Z. These are our lowercase p's. And then in column C, these are the probability that the Z value is less than this value here that you see on the table. So what is the probability of any value of Z less than that? Okay. So those are the cumulative probabilities. All right. So get those typed in, and then unpause the video and come back. So now that you've unpaused, we're going to continue to fill in these numbers so that we can create our graph. So in cell B3, we're going to type equals, and then it's NORM dot D-I-S-T, norm.dist, parenthesis, and then the value that we're interested in is A3, comma, and then the mean is 0, comma, and then standard deviation is 1, comma, and then cumulative is false. Cumulative is false, close parenthesis. So again, that's equals norm.dist, parenthesis, A3, comma, 0, comma, 1, comma, false, close parenthesis. And we only have to enter that in once, and down here in the lower right corner, when you see that black plus sign, it means you can click and drag. So we're going to click and drag the formula all the way down. These are going to help us to create our bell curve. So let's select from A2 all the way across and down to B19, which is where all of our data is. So again, just select. Do not try to fill or do anything like that. We're just selecting those cells, and we're going to go to the Insert tab, and we're going to make a chart or a graph. So the chart we're going to make is a scatter plot with smooth lines. Scatter plot with smooth lines. And there you have our bell curve that measures probabilities for z-scores. So we're going to call this standard normal. Standard normal distribution. So instead of looking like a histogram, it actually is a smooth curve because this is a continuous distribution. It's a continuous random variable. Also, I want to reset. I want to make sure these numbers that are showing down here are all of the numbers that I included in my table. So I'm going to go to Format Axis here. Format Axis. And under Units, where it says Major, right now it's 1.0. I'm going to change that to 0.5. And there we have the all of the z-scores are labeled that are on my table. And so that's a standard normal distribution. That's what it actually looks like. But again, the probabilities of outcomes are always going to be probabilities either in between two values or to the right of a value or to the left of a value. So let's fill in our cumulative probabilities here. In column C, in cell C3, type equals, and again it's norm.dist, parenthesis. So the same thing we're going to type in, except this time instead of saying false, we're going to say true. So norm.dist, parenthesis, A3, comma 0, comma 1, comma true. So now the cumulative is true. And that is a very tiny decimal, which is why you see it in scientific notation there. So let's change that from scientific notation to just a number format. And it just shows up as 0 because there's only 2 decimal places. So let's increase the number of decimal places that are displayed, and that will give us the actual probability of any z value being less than -4, and that is extremely small. So we're going to again choose that anchor in the lower right corner and fill the formula down. Fill that formula down. So just to show you what this means, let's focus on this value right here, where it says z equals 1 and the cumulative probability is 0.8413447. So on our graph, the way that works is it's the area to the left of z equals 1. It's the total area to the left of z equals 1. And that is the total probability of any of these outcomes of z happening from, as far down as you possibly can get all the way up to z equals 1. And that's the area under the curve. That's 0.8413447. Okay. Z-scores are really just measuring distance from the mean. So the probability of being less than 1 standard deviation from the mean is 0.8413. So about 84% of all of your data, if it's normally distributed, is going to be less than positive 1 z-score. If we wanted to know what the value is between, for example, we want to know what the probability is in between two z values, we would just calculate them up here just using a standard calculation that's basically norm.dist of the right value minus norm.dist of the left value. So the probability between positive 1 and negative 1, so if I highlight that, what if we wanted to know the probability between those two values? So basically these two numbers here, the two cumulative probabilities, would have to just be subtracted. So basically let's just say that we wanted to know between positive 1 and negative 1. So that's what I'm describing that here. So let's kind of move this over. I'm going to expand this. So between positive 1 and negative 1. So I've highlighted those numbers in the cumulative probability thing. So over here, I'm just going to type equals, and I'm going to take the value from C13 and subtract the value from C9. Okay, so we're subtracting the two cumulative probabilities that occurred at the two values that we're interested in, the area between. And when I hit the enter there, that's about 68. It's 68.27, basically 68.3. So 68.3% of all values that are on a normal distribution are going to fall within 1 standard deviation of the mean. So those are just areas under the curve. So for our next video, I'm going to work on filling in some more detail on this graph so that you can actually see where those probabilities are and what they have to do with calculating probabilities of actual random variables that have a mean and a standard deviation that's not 0 and 1. Like, subscribe, comment down below, share these videos with people if you find them useful, and that is your introduction to the standard normal distribution, the z-table or the z-score. Thank you very much.